welcome to everyone to this fifth and last event before summer break of the EMSWebinar series. Let me start by noting that this webinar is being recorded and will be published later on the EMS YouTube channel. Please send your proposals, your suggestions of new topics and speaker to us. Whatever topic you consider could be attractive or interest would sure fit in this format. First, I will start with a few words about formalities. First, we'll have a presentation delivered by our invited person, roughly 30 minutes, and then we'll invite questions from the audience via the chat function. That will be only seen by the panelists. Please use the chat to write your questions. Also, you can raise your hand clicking in the corresponding icon on your screen. In this case, turn your micro on and your camera if you wish. And now we turn to our today's speaker, who is Francisco Doblas-Reyes, Paco for his friends. He's a research professor and director of the Earth Science Department at the Barcelona Supercomputing Center. He has a long research experience covering understanding, simulation, and prediction of climate variability and change, and also has started working on climate services around 10 years ago, who is the main focus of this talk. He has participated and coordinated many, I would say, research projects and initiatives related with his research interests. He is author of more than 200 peer-reviewed papers and has a long record of obtaining competitive computing and financial resources to support his research. He is member of several international panels. He also is direct supervisor of senior scientists, postdocs, PhD students, senior engineers, junior engineers, and regularly work with a large variety of persons. He was also coordinating lead author of the most recent IPCC assessment report, and also lead author of the previous assessment report. And finally, author of the first European climate risk assessment report. Okay, and he has, just to finalize, heavily involved in the design of the sixth couple model intercomparison project, which provide with data to IPCC reports. Today, Francisco Paco will present the requirements for the operationalization of climate projections, including the initial steps in this direction, including also the role of recent development based on machine learning techniques. The title is operationalization operationalization of climate projections. Please, Paco, go ahead with your presentation. You have the floor and 30 minutes. Thank you.
Okay, thanks very much, Ernesto, and thanks to the EMS for this invitation to participate and give a webinar here, or at least to share some ideas with the audience. I could see in the audience a lot of friends and colleagues, and so it's very nice to see that they had interest in listening to some of the things that I've been working on the last months and a couple of years. I would also like to add to what Ernesto said about when he was describing my bio, is that working with all these different people has given me the opportunity to keep learning from many different domains, and that this is really exciting, the possibility of working with people with a very different background, very different experiences, and it's really exciting to still have the opportunity to work in a very multidisciplinary environment at the Barcelona Supercomputing Center, and also to work in many projects in which I have the chance to keep learning and getting very exciting ideas from this variety of people. As Ernesto said, my talk is about the operationalization of climate projections. The first problem that people find with the climate projections in an operational environment is the difficulty of saying operationalization. It's somehow it's a word that my impression is that it will be used increasingly in the climate domain, at least in the climate change domain, in the next few years. And I'll try to explain why these words make sense compared to the status quo that we had until very recently. Let me start with a metaphor, and what I'm showing here on the left is a production chain of one of the Mercedes factories, and the one on the right, it's a concept car. It's a very nice concept car that was built in the last decade. It's a silver lining Mercedes that was basically an inspirational work that some Mercedes engineers built, and this hopefully will allow me to describe the thread that I want to follow in this presentation. The image on the left, it's a production chain. So basically, it's producing cars. The whole chain is reproducible, so the cars can be traced back to where in the chain was each one of their elements installed and created. It's based on market studies, so the market has been sampled and analyzed, and somehow these products are following a market analysis that discovered that they could have a place in the market. They also have to follow very strict quality control and standards, to say the least, related to security. And the production is scheduled, so the number of cars that are going to be produced every day, every month is known in advance, and this is because people order their cars in the shop, and they want to have their car when they have been told that their car will arrive. And there are many other aspects that basically describe an industrial production of a product. The one on the right, it's a one-off, so probably this is the only car that was made. It's likely not necessarily reproducible. You can try to mimic, but probably it won't look exactly the same that was produced as a concept car. It doesn't really obey the movements in the market. It might be used as a publicity tool, but it's basically something that has been built for many different purposes, including image, but also investigation and development of different elements that might make their way or not into cars that are produced in a series in a factory. The car might not necessarily follow standards or any specific quality control. It might not be even susceptible to be driven. So it's a car that but it's following exploratory requirements and motivations. So the one on the left and the one on the right, they are all produced by the same company. It involves at times the same engineers that might be moving from the research laboratory to the factory and the other way around. But they are completely different things, even if they are very interesting and very useful for the automobile industry. So I'll go back to those images at the end of my presentation to try to explain in what way climate projections relate to that metaphor. But let me go now to the climate domain and start by saying that, well, we won't be surprised by the increasing role that climate information for the future plays in many sectors in society, in the private world. The likes of Deloitte and also many other smaller companies are providing climate information for adaptation, mitigation, and disaster risk recovery. We also have public administrations. The European Environment Agency, which is an agency of the European Commission, is preparing reports like the European Climate Risk Assessment Report that uses climate information to assess climate-related risks. The IPCC reports are probably one of the most influential elements that enter the whole climate discussion at all levels, policy level, adaptation level, citizen level even, and they are using climate information for the future in a large part of the different volumes that are published. And the conference of the parties that are taking place every year are also based on a lot of the information that is being extracted from the climate projections to undertake in the negotiations about emission reductions, climate adaptation, and funding for both aspects. So climate information for the future is pervasive, and it's really penetrating in many different sectors of society. But what is climate information? So if we look at the diagram on the right that is taken from the latest IPCC reports, we can see at the top that there are sources of climate information that are used for the climate information construction. They are different. It's not just data. It's many different things, including expertise and understanding. And all this is synthesized in the reports, and that is based on all the literature that has been produced in the previous years into climate information that has many different shapes, like data, storylines, graphics, and many other, and then is converted using a virtual circle into user-relevant climate information that makes its way into additional requirements for the production of new sources of climate information, be it observations or simulations. And this is now called a co-production process in climate services, and somehow it allows to distill the relevant information for society from the knowledge and data that we have in the climate domain. The climate information is not produced in isolation. This co-production process that needs to be framed, taking into account the context and the values of those that are going to use the information, involves many actors, and that it involves the producers of this data, that is also relying on scientists that are developing the systems, both for observing and projecting the climate, and also assessing the impacts of the climate changes on society, and the users that are going to make use of the information that is being produced. So there are many different actors, there are many different sources, and the process is actually quite complex, and it requires a lot of coming and going to be as equitable as possible in the final product that is delivered. But for climate projections, one needs to also be aware that they enter the whole cycle only in a specific part. It's not that climate projections per se are the climate information for the future. They're just one element in a very complex chain. And this is what I tried to illustrate with the red square that you find in the top right. So climate projections, which is, as I said before, a source of climate information, are produced using a range of models and also a range of requirements and interactions that are taking place. So for instance, one of the first things that are done is to consider for the future how the emissions are going to evolve, the emissions that are relevant to define physical climate change. So CO2, methane, also non-CO2, other non-CO2 greenhouse gases like nitrous oxides, and also other factors like the land use and albedo that play a role in defining the trajectory that our climate system is going to follow into the future. Often these evolution of the emissions obey to policy-making requirements. Other times they are emerging from the interest of the research community. Those emissions of relevant gases and species in the atmosphere are converted into concentrations that are used in simulations of the Earth system using global models, which basically converts those changes in the concentrations into changes in the radiative forcing of the atmosphere, which leads to the projections of global warming that we know and that we have seen many times in the IPCC reports and in many other reports like those that are used for climate adaptation. So the climate information, the climate data that is coming out of these simulations is delivered often in the form of climatic impact drivers, which are the drivers of systems that are not necessarily physical climate systems, but are those that are representing the sectors in society that are vulnerable to climate change. The current climate information sources for climate projections includes mainly the CMIP exercise, so the coupled model intercomparison project, which for which you can see an illustration of the next cycle, which is called CMIP 7, and that somehow it brings together the physical climate modeling community around the world in a very complex and rich exercise to perform coordinated simulations with many different climate models and that deliver their data in the public domain for anyone who is interested in using these data about the potential evolutions of the climate system until the end of the century and beyond. Many global models are used. They are research-driven, and I put here research in red on purpose. The resolutions of these models are relatively coarse. The best, they have resolutions of around 50 kilometers. If you work in a med service, you'll be fully aware that there are many other processes that are relevant to the atmosphere and the ocean, and that are active at much higher resolutions. There are another important aspect of CIMIP is that between the different cycles of CIMIP, so between the different phases in which the different models agree on performing the coordinated experiments until the next one, there are many years between those cycles. And the archive that is produced is very rich. It's incredibly complex to curate, but it's static. So once it's there, it doesn't move anymore. The users that don't find what they want there have to wait for the next cycle. Cortex is another really important element in the sources of climate change projections. This is an ensemble of regional climate models that are run over different regions in the planet. They are not global, so they have to choose the region of the planet where they are going to perform their simulations. There are many regional models that are participating. Not all the regional models are used in all the regions that appear marked in red in the map. They are also research-driven, so they are performed mainly by research institutions. Some of the Met services around the world, they also produce these kind of simulations, but they are mainly produced by their research departments in their meteorological services. The resolutions are higher than the ones in CIMIP. There is also a long time between cycles, similar to the ones we have in CIMIP, several years, between 5 and 7 years. Often they are not coupled to the ocean, which is an important component in particular when we go to high resolutions. And this archive is also static. So we have really valuable components here that underpin the production of regional climate information, CIMIP and Cortex, but they are research-driven, and there are very long periods between which the users have to wait if they want specific additional simulations or data. Can we do anything different? Can society at the global scale consider having something that is not just research-driven? Well, there is an opportunity which can be associated with the WMO infrastructure. So WMO aims to, among many other things, make operationally available products for weather, climate, hydrology, and other aspects of the environment that are available, as I said, among the WMO members, and especially to relevant operational organizations. And I emphasize here the word operational. The second aspect is that it establishes a global network of operational centers that are coordinated and operated by WMO. In particular, in the WMO infrastructure, we have the WMO Integrated Processing and Prediction System, which is called WIPS, which is the one that is structuring the flows of information and data between the designated centers, so those centers that are producing data, forecasts, observations around the world, and those that are consuming it, other national meteorological and hydrological services that are delivering that the corresponding information to their societies, and also in the end to the general public and user sectors. WIPS, so the WMO infrastructure, is can be consulted in this web portal, and it has many different activities that are contributed by many different countries around the world from the 5 continents, and that plays a key role in the civil protection and in many aspects of the economy in all the countries of the WMO system. This is a list of the WIPS activities. There are general purpose activities, there are non-real-time activities, and there are also specialized activities that try to target specific aspects that might not be continuously required, but that might be also relevant in specific occasions, like, for instance, the nuclear emergency response, which is quite critical. But in any case, none of these activities is related to climate projections. So WIPS, WMO, is coordinating, sponsoring, and making sure that that information is reaching all the countries of the WMO system, but they are not responsible to producing and delivering any climate projections. We might think that it would be enough to rely on CMIP and Cordex to do this, but don't forget that CMIP and Cordex are research activities, and as research, they have a big difference with what WMO is doing, which is the operational aspects of WMO. So there is a commitment of all the Met services to WMO, in particular the designated centers, to provide the data that is relevant for the WIPS activity they are involved in. It could be the short-term weather forecasting, it could be observations, or it could be many other of the activities that are listed here. However, nothing about climate projections. And this is really worrying, in particular, given the penetration of climate change decisions in all aspects of society. There are some activities that have made a move from pure research to an operational activity along with along the WMO guidelines. This is an example. There are others, but it's the one that I know best, and it's the decadal climate prediction, which tries to make predictions of the global climate for periods of up to 10 years into the future. These predictions are performed once a year. They are delivering to the LEAD Center, which is located at the Met Office in the UK. And the LEAD Center is coordinating with WMO the formulation of a report that informs all the Met services and also the public about the likelihood of significant changes in the climate system in the next few years. So this is possible. It's possible that some activities from research can make their way into operations. The only thing is that they have to be promoted by the actors, the key actors in the WMO system. In the particular case of decadal prediction, that was done by the World Climate Research Program. WMO is also taking into account that there are many other aspects related to climate projections, like, for instance, guidelines for the use and interpretation of the climate change projections at regional and national scales, which is a key component of the Climate Services Information System. This is part of one of the mandates that has received the Commission on Services of WMO, and there are already activities, there are workshops that are taking place to design and release these guidelines for the interpretation of the existing climate change projections. However, the mandate doesn't include the production of new simulations for future scenarios. So it's obvious that we need climate projections that are provided by a different framework that is not just based on research, and that is basically at the mercy of the research budgets, which come and go, but that is much more operational in the sense that there is a commitment to make those projections and those simulations on a regular basis, probably much more regularly than what is done by CMIP and Cordex. And this is what is that has been formulated in the last few years in a number of papers that appeared in the literature, which basically confronts the traditional way of making climate projections that are driven by research, in which the simulations are basically designed by climate scientists with the best of their intentions, but hoping that what they have in mind, that the users are actually looking for, is what they are going to deliver. However, when one is confronted or being exposed to what society is actually expecting from these climate projections, one can find out that there are many questions that are falling through the cracks and that are not being taken care by those climate projections that are formulated in the research domain. Like, for instance, what is the possibility of a different trajectory if the emission commitments are not respected in the next 5 years, in particular for methane. So there is currently no infrastructure that can take these kind of questions into account. CMIP7 is making a big effort to cover some of these gaps. And for instance, they have created what they call the CMIP7 Fast Track, which has been created to make these simulations, produce the simulations for the climate change projections for the 21st century much earlier, to feed the next IPCC report, which is expected to be published before the end of this decade. This fast track feeds from it's fed from historical forcings and the scenarios that are being designed as we speak here, and that are being created by a handful, again, of scientists that are making a huge effort to produce these kind of forcings that will drive the climate projections that will be part of CMIP7. So there is an awareness that things have to change, and they have to be faster, and they have to somehow give a bit more time for the analysis of the simulations that are going to, in this case, be part of the IPCC. However, there are many other users that are not taken into account in that cycle, and it's not the fault of CMIP or Cordex. It's just that there is a myriad of users out there that might have specific requirements and that might be interested in climate trajectories that are much more relevant to them than the ones that are considered in the physical climate models. One of these efforts is undertaken by Destination Earth, which is a European program funded by the European Commission, and that is developing a digital twin for climate adaptation, in which basically a new way of producing climate data for climate information at local and regional levels is being designed. There are many aspects in this digital twin that might be relevant, but one of them is that it has been designed as an element, as a way to illustrate what it takes to operationalize climate projections. And in particular, there is a long effort that has already been taken place in the last 2 years to make the most of the software engineering developments that have taken place so far in other domains, the introduction of artificial intelligence, the much better and more user-oriented data handling, the use of a new generation of climate models, and so on. But what is really important here is that the whole digital twin has been designed, taking into account that user requirements should be taken into account from the beginning of the simulation, not when the simulations are already performed. The models used in the digital twin of Destination Earth are a new generation of models. They won't solve all the problems that we have in physical climate modeling. They are just one step forward, but they are the recognition that these models that have very high resolution and are very, very expensive to run are trying to address a problem that has been in the physical climate domain for a very long now, which is the fact that there are systematic errors that persist from one CMIP cycle to the next, and that are leading to the overconfidence or underconfidence of the statements that are being released in the form of distillation of the climate information for the future. That might that might induce additional risks and might also undermine the credibility of these simulations for the future. Of course, as I said before, there is much more than resolution in all this, but somehow it's important that we all agree that, as it happens in weather forecasting, the current tools that we have to perform climate change simulations for the future is not fit for purpose, because it requires much more to satisfy requirements that have been identified already. One of the aspects that needs to be integrated in climate modeling, and in particular in the design of not just the models that we use, but also the way we run and design these experiments, is that so far we have been very much concerned by the uncertainty of the data and the simulations that we are performing. So there would be the lower left part of this quadrant that you see on the right. However, there are other aspects that we have, and I talk as a climate modeler, we have probably underestimated in the way we are working, which includes the ambiguity of the problems that we are formulating, and that's where philosophers of science can be very useful if they are happy to team up with climate modelers. And also the ignorance and the making explicit the known unknowns that we have, and also acknowledge that there are unknown unknowns that will for sure affect the information that we are providing for such a long future, such as the end of the century and beyond. And this is only one example of this kind of known unknowns that we have, in which there are indications that a new generation of models actually, when they reproduce the ocean circulation in a much more detailed way, and they include also the contributions from the ice sheets in a more realistic way, they lead to futures that are compatible with the forcings that we have right now in the atmosphere, that lead to physical climate impacts that are much bigger than the ones that we have considered so far. It doesn't mean that the future needs to be that way. It means that it's possible and needs to be taken into account. And my last slide, going back to the initial metaphor, and I hope that the metaphor was, well, good enough. As I said, on the left, we have a production chain. On the right, we have a concept car that is very nice, and it's really satisfying those that produced it. In the end, we have to acknowledge that the operational climate projections are something similar to a production chain that timely respond to the demands of policymakers and society, and that will imply not just moving the CIMIT models to an operational environment, but also thinking on many other aspects that are absolutely necessary, like standards, quality assurance, at the full reproducibility, and many, many more. So the one on the right actually is illustrating how important it is to have a really solid research component to develop the new generation of climate projections that take into account the both scientific curiosity, but also aspects like ambiguity and ignorance that bring us well beyond what we can do with the discussions that we've been having so far into the uncertainty of the climate projections. And that was my last slide. I'm sorry that I overrun 3 minutes with respect to what I was granted, but yeah, I hope it was clear enough. Thanks very much for your attention.
Thank you very much, Paco, for this exciting trip describing the transition from research to operations of climate projection and what this transition implies. Now we move to the questions and discussion part. Please formulate your question using the chat or raising your hand.
So thank you very much, Paco, for pointing out all these complexities that are related to climate projections, which, in my opinion, will make it necessary to be a lot more precise about what we mean by operationalization. And thank you for pointing out that's an impossible word to say the first time round. Looking at the list of activities that you pointed out, WMO already does operational. There's one thing that jumps to attention, in my opinion, and that is effectively those are things that are repeatable, and the repeated, the cycle of repetition is dictated by initial conditions. It's weather forecast, it's predictions, what are the initial conditions in other parts of the complex system. So first question is, what would you see in the climate projection arena being the trigger for the repeat of the cycle? A change in the boundary conditions, a change in models. As far as I know, there is no clear understanding as to which is the relatively more important. I also know, as do most people here, that once a new round of CMIP happens, the old CMIP usually is left in the background, but it is not scientifically declared obsolete and completely accounted for by the new version of it. So I think a better understanding and the formulation of the theoretical problem of how do we regard past climate projections when new rounds come up, whether it's at a tighter interval than now, the regular interval, whatever you might want to think operationalization means primarily. We need guidance as to how to do that. It's not like in weather forecasting where today's forecast completely negates those from the past. So I just wondered if you have any more to say now, or you just like to agree with me that this is a big complexity that is yet to be worked on.
Yeah, not much more than what you said. So it's a big complexity, and it's something that, for instance, I hope will emerge at the WMO workshop that is taking place next week in Washington. That neither you nor me can attend, but it's in my opinion, should be already including and integrating these kind of questions. Because as you say, if we go into an operational environment or an operational setup, one has to provide very clear messages to the users of what is the valid source of information for a specific valid time. No, it could be the valid time in mid-century. It's interesting that at the last IPCC, when we were preparing AR6, we were asked to include in all the plots and in all the analysis both CMIP5 and CMIP6. And that was first because CMIP6 was too recent, and that's one of the reasons that is somehow moving CMIP to have this fast track. And the other one is that there is no real policy, there is no real understanding of how to discard or whether to discard a previous CMIP cycle. I think with Cortex might be a bit easier because the cycles, the Cortex cycles are a bit longer. But for CMIP is definitely not clear. And it's a discussion that is not even taking place. So it's very good that you bring it up.
And in particular, let's try to invite users to bring their perspective to this discussion, or try to put ourselves in their shoes at the very least, because even the perspective of producers is hard to clarify and quantify, let alone somebody who used projections 10 years ago to build a bridge or to build a road. What are they to do when CMIP6 comes up and changes the interval of vulnerability? Do they just remove that bridge and build it again? It's a very important consideration to bear in mind. Thank you.
Absolutely. Yeah, I completely agree with you, Anka. But sorry, your first question was what would justify or what's really
would trigger?
Yeah, what would trigger a new cycle? For me, the four things, the scenarios that will be feasible or plausible in the future, is changing every very few years with the current geopolitical situation. The uncertainty about the trajectory that those scenarios might take is very large, and scenarios that might have been considered plausible or even interesting 10 years ago might not be in the interest of the policymakers anymore. So for instance, for overshoot scenarios, most of the information that the European Commission is using which is through the Provide project. It's a Horizon Europe project, are coming from emulators, which are very respectable, but they need to be contrasted with other alternative sources like physical climate models.
That is very true, but I would also argue that different models give different answers to the changes at regional level. Therefore, I mean, I'm saying this because I have been in meetings where the modeling community argue that they want to wait for the new version of the models to run the forcings. And this is because at regional scale, if you look at the climate, at the policymakers and the global averages and large-scale long-term trends, maybe forcings are the first order change. But I think at regional level, there's much of the uncertainty also comes from the models formulation.
Yeah, absolutely.
There is a question in the chat. Marina Maldicera Pachetti, sorry if I am pronouncing not right, said, I was wondering if you could say more about how you envision quality to differ in the context of research-driven information and operationalized information, if at all.
Okay, thanks a lot, Marina. Nice to see you writing online. Well, this is a question that we can bring to the Climate Europe 2 project. This is a Horizon Europe project in which both Marina and myself are involved, that tries to decide in what way climate services should be standardized and which components should be or should not be considered for standardization. To be honest, I have no real answer. So I know that it will be very different when I've been talking to the other colleagues, other researchers, and we talk about the experiments that we consider interesting and useful, and at times we are brave enough to say, oh, that will be useful for the users, which is going a very long way from what we can actually do with our models. The quality questions that are on the table are very different to the ones that we are discussing in a more operational environment, like the ones in the Climate Europe 2 project, that is thinking on how standardizing the climate services sector to also guide the market that provides those climate services. So luckily, we have in the Climate Europe 2 project many social scientists and researchers from humanities that can guide us in trying to answer this question.
There is another one from Spain. First, the comment, excellent and inspiring presentation. Just a small challenging question. How to involve communicators to support this huge effort from EU institutions and national governments? Just after the EU elections, national made services are trying to follow and support EU directives and efforts, but also need national support and alignment with EU policies and initiatives. Thanks a lot.
Yeah, that brings along the question of policy and public administrations, but in particular policy in the field of how to shape an operational activity. I wonder in what way weather forecasts are being shaped by policy. That would be really interesting to really consider what aspects of weather forecasting in the WMO context is being shaped by policy. I guess that climate change in particular is coming along with additional attachments. Climate is a very politically laden side. It has somehow other aspects that haven't affected weather forecasting, or at least I'm not aware of. and that has to be also being taken into account. In what way we have to shape this discussion about the operationalization of climate projections to support the efforts from all those public institutions, in particular governments, both national and international. To be honest, I don't know. But it would be really interesting to know if there is some help that can be produced from WMO on these respects.
Thank you. Thank you, Paco.
But in any case, I think these are questions that somehow the operationalization will bring forward, and that so far have been left in the a bit hidden with all the discussion about believing or not on climate change, or the uncertainty of the climate projections. I think there are many other aspects that are very important that have to do with the social value and the political aspects of climate change that could condition the way we design our climate projections. I don't have the answer. I just have the feeling that as soon as we put it in a completely different framework, other domains outside physical climate modeling will come with very interesting contributions and questions.
Thanks again. I agree.
Ernesto, no other questions at the moment. You can say what you want.
Yeah, thank you. Well, it's about the current strategy for production of ensemble of climate projection, which is mainly based on an ensemble of opportunity. To use the models you have available. There is no possibility in principle to choose one or another. Or can you say something about a future better strategy for exploring uncertainties, considering the fast developments we are envisaging based on machine learning techniques?
Okay, yeah, very good question, Ernesto. Well, there are several. One of them is the use of machine learning and the training of machine learning emulators on the current climate change trajectories that have been already produced by the existing climate models. So basically CMIP, CMIP 7 when it happens, Destination Earth, and then use this emulator to do a proper exercise of uncertainty quantification. It could be uncertainty quantification to the parameters of the models themselves, or it could be uncertainty quantification of the forcings of these scenarios that we're considering. It would be nice if one of these emulators could help us explore the space of the different scenarios that we haven't actually simulated yet. So that presents really exciting prospects, and we won't have to wait very long to start seeing some results on that front. So the Helmholtz Association in Germany is already building a foundation model for that is expected to include also not just the information about the physical atmosphere as we have with the very well known now medium range weather forecast systems that are being announced by in particular private actors, and that are very nicely monitored and compared by ECMWF, but something that is including more intrinsic information that is relevant to climate change, the forcings, the role of the ocean, and other aspects for which we have even a bigger uncertainty. So AI will definitely help, and it's an exciting time for this. The other aspect that I find very interesting is very high global resolution modeling. Again, as I said before, this won't give us the answer for everything, and those simulations will come along with additional biases and lots of things that don't work. But the really interesting aspect is that they are helping us with some of the ignorance that we acknowledged about the climate projections that we have now. So the generation of very high resolution global models, there are not that many around the world, but there are some already that are being run, and they are illustrating a very different behavior of the ocean. And the ocean is key in climate change projections. It's the main driver after the forcings. And what we are seeing is that resolving all those eddies that you can see in the image behind me in a model induces a different behavior in the large-scale ocean circulation that can affect aspects as important as the melting of the ice sheets in Antarctica, or that can affect the ocean heat uptake capability of these oceans, or even it can change the interaction between the ocean and atmosphere and give a slightly different climate change signal in parts of Europe. So again, this is something to be explored in much more detail, but it's also very exciting. But to me, one of the things for which we don't have an ensemble of opportunity, we have plenty of climate models. We have lots of people looking into the scientific aspects of the current and future climate, but we have very few people who are able to produce estimates of the past forcings and that are able to produce credible scenarios of emissions for the future, and that can do these kind of things very quickly, as we might need in an operational environment, in particular if we have to address the questions that policymakers, in particular those attending the COPs, will be throwing at us. So it's a very exciting time. Lots of things are changing. I'm a bit old now to really ride the wave, but I hope that I can push others to really catch the right wave and have a great time.
Thank you. Vesna, are there any other question? No.
No.
Okay. If not, thank you, Paco, for this challenging talk, and everyone for attending. We'll come back after summer break with, I hope, with renovated energy and proposal. And once again, I invite all participants to submit ideas for further speakers, topics. Please use the email of the EMS Secretariat. And that's all from my side. Enjoy your summer. Goodbye.
Thank you.
Bye. Thank you.